Everything in Python is an object. Your numbers, your strings, your lists, all objects. But what if you could create your own custom objects from scratch, designed to work exactly the way you want? That's the power of classes, and by the end of this video, you'll know exactly how to use them. Welcome back. Today we're diving into one of the most important topics in Python classes. We'll cover what a class actually is, how to build one from scratch, how to give your objects unique starting values, how methods work, and why any of this matters in real projects. Let's get into it. Section 1. What is a class? Think about a cookie cutter. The cookie cutter itself is not a cookie, it's just the shape, the template. When you press it into dough, you get a cookie, a real, physical thing. Classes work exactly the same way in Python. A class is a blueprint. It defines what something should look like and what it should be able to do. An object is what you create from that blueprint. It's the actual thing your program works with. Here's a simple example to make this concrete. Imagine you're building a program to manage a library. You have dozens of books. Each book has a title, an author, and a number of pages. Instead of creating separate variables for every single book, you can define a class called book. That class becomes your template. Every time you need a new book in your program, you create an object from that class. The technical term for creating an object from a class is instantiation. The object itself is called an instance. So if you create 3 book objects from your book class, you have 3 instances of that class. They all follow the same blueprint, but each one holds its own unique data. This is the fundamental shift that classes bring to your code. Instead of thinking in terms of individual variables, you start thinking in terms of things, real-world concepts that have data and behavior bundled together. But how do you actually write one? That's coming up right after we look at the basic syntax. Section 2. Defining a class. Writing a class in Python is simpler than most beginners expect. You use the keyword class, followed by the name of your class, followed by a colon. By convention, class names start with a capital letter. So for our example, you'd write class book with a capital B, then a colon. Everything inside the class is indented, just like functions and loops. The class body is where you define everything about your blueprint. Now, the first thing you almost always define inside a class is a special method called init. It's written with double underscores on both sides, __init__. This is called the initializer method, and it runs automatically every single time you create a new object from the class. Inside init, you define what data each object should start with. The first parameter is always self. This word self refers to the specific object being created. Through self, you can attach data to that object. So for a book class, inside init, you'd write self.title equals title, self.author equals author, self.pages equals pages. These attached pieces of data are called attributes. Every book object you create will have its own title, its own author, its own pages, all stored as attributes on that specific instance. To create an actual book object, you call the class like a function, my_book equals book, then in parentheses, you pass in the title, author, and number of pages. Python immediately runs the init method behind the scenes, sets up all the attributes, and returns a brand new book object. Pretty clean, right? But attributes only store data. What if you want your objects to actually do things? That's where methods come in, and they're more powerful than you might think. Section 3. Methods. A method is just a function that lives inside a class. The difference is that a method has automatic access to the object it belongs to, through that self parameter we talked about earlier. Let's say every book in your library can be described in a quick summary. You could write a method called describe inside the book class. It takes self as its only parameter, and inside it you return a formatted string that includes self.title, self.author, and self.pages. Now when you have a book object, you can call that method directly on it using dot notation. You write my_book.describe with parentheses, and Python will print out a nicely formatted description of that specific book. Notice how self handles everything automatically. You don't pass in the title or author when calling describe. The method already knows them through self. This is one of the biggest advantages of classes. Your data and your behavior travel together as one unit. You can add as many methods as you want. A method could update an attribute, compare 2 objects, calculate something based on stored data, or interact with other parts of your program. Methods are what make objects truly useful. Think about this. If you had a student class, you might have methods to calculate a GPA, check if a student is passing, or print a report card. All of that behavior lives right alongside the data. But what happens when one class needs to build on another? Hold that thought. Section 4, Inheritance. Inheritance is where classes become incredibly powerful. It lets you create a new class that automatically gets all the attributes and methods of an existing class, and then adds its own on top. Here's the real-world logic. All ebooks are books. They have a title, an author, and pages. But ebooks also have a file size, which regular physical books don't have. Instead of rewriting your entire book class from scratch for ebooks, you can create an ebook class that inherits from book. To do this, when you define ebook, you put book inside parentheses after the class name. Now ebook automatically has everything book has. In ebook's init method, you call super.init to run the original book setup, and then you add the file size attribute on top. This eliminates code duplication, which is one of the most important principles in programming. When your book class gets updated, ebook benefits automatically. When you have dozens of related object types, inheritance keeps everything organized and maintainable. This is the foundation of what programmers call object-oriented programming, a whole style of writing code built around classes, objects, and relationships between them. But before you go off and write your first class, there's one more concept worth knowing. Section 5. Why classes matter in real projects. You might be wondering, do I really need classes for small scripts? Honestly, sometimes no. If you're writing a quick automation or a simple calculator, functions and variables are fine. But the moment your project grows, the moment you have multiple related things with data and behavior, classes save you enormous amounts of time and headaches. Every major Python framework, from Django to PyTorch to Flask, is built on classes. Understanding them means you can read real-world code, contribute to real projects, and build things that actually scale. Classes also make your code easier to debug. When something breaks, you know exactly which object to look at. Everything is organized around logical real-world concepts, instead of scattered across dozens of separate variables and functions. The professionals you admire aren't writing thousands of lines of tangled code. They're writing clean classes that each do one thing well. That's the skill that separates beginners from developers who build real products. All right, let's recap. A class is a blueprint for creating objects. You define one with a class keyword and set up starting data inside the init method. Methods are functions inside a class that can access and work with that data through self. Inheritance lets one class build on another without repeating code. And classes are the foundation of almost every serious Python project you'll ever encounter. Now it's your turn. Open up your code editor and try writing a simple class. A car, a student, a recipe, whatever interests you. Add a couple of attributes, and at least one method. Seriously, 5 minutes of practice right now is worth more than rewatching this video 10 times. If this helped you, hit the like button. It genuinely helps this channel reach more people learning Python. Subscribe so you don't miss the next video, where we go deeper into object-oriented programming with more advanced class features. And drop a comment below with whatever class you decided to build. I read every single one. See you in the next one.